Only 4 of you have submitted the assignment. The first assignment that I sent out, it's been 2 weeks. So submit the assignment for Unit 2 strings before this Saturday, and I'll be sending out the assignment for this Unit 3 by Sunday, so that you can complete the next assignment. Okay.
Okay, thank you.
So guys, this session is recorded, and yeah, do what PK has said. And it takes a lot of effort to put those assignment questions. It's only to help you understand the concepts better and show you how easy concepts can be twisted to look more complex. But if your fundamentals are clear, you can tackle even those problems quite easily. So take it seriously and submit the assignment before the time is up. And before we start, I would like to kind of apologize for last session. I don't know why I thought we were time up half an hour before time. So that kind of set us a little off from the planned topics for last session. So without wasting any more time, if there's no more question, no more conversations, let's start with our session today. And next thing you'll see is my screen. I hope you all can see my screen now. Feel free to unmute yourself and ask questions or get any clarifications. So last session we ended somewhere here. We looked at this first question. It's kind of a good take at it, like it's a good assignment, fun assignment to do. Sorry. There must be a glitch. So moving on from where we stopped last time, we're looking at if, else, and a series of if, else's. We kind of looked at when to use if and limitations of if, which is if only executes when condition is true. So we need else, which kind of executes when condition is false. And then we looked at if we have to chain multiple if else's, Java provides a mechanism to do that. But similar functionalities can be achieved with individual if and else's as well. But if else's, but interlacing if else makes it a little easier and makes the look code clean. So that's where we left last time. Let's start with logical operators and truth tables. This portion of if else is a little theoretical, but it's good to have an understanding of it because it helps build Boolean expressions, which will Boolean expressions are the one which evaluate to either true or false. And that's what is used in if else. And the next topic that we're going to cover is iteration loop. So they all heavily depend on Boolean expressions, and these two topics, if else's and loops, cover a very significant portion of AP coursework. So understanding logical operators and truth table is very critical. By any chance, have you all ever come across truth tables before?
What's a truth table?
All right. So
is it just like that table?
Yeah, it's kind of that table, and something like such is also a truth table, and then something like such is also a truth table. So it's like a concept in computer engineering, wherein you create a table, you have a variable, and then you create a table of what will be the outcome of an operation between those two variables. As an example, the first table is a truth table for logical not, which means if your variable is x, a Boolean variable is x, and we're doing a logical not for it, which is exclamation of x, if the value of x is 0, its logical not will be 1, which means if the value of x is false, its logical inversion will be true. Similarly, if the value of x is 1, its not of x will be 0. So the truth table of logical not is only 2 elements, because x can have either a value of 0 or it can have a value of 1. And that's because it's a Boolean expression or a Boolean variable, and it can only hold true or false, right? So that table is pretty short. But now when we look at the next truth table, which is we want to see if you have two variables, Boolean variables, x and y, what is the output of when you do logical operation of ANDing of x and y. So as x can be true and false, y can also be true and false, which means each one of them can have two combinations, and therefore between two of them there can be four combinations. So the first combination is x is false, y is false. So a logical AND of x and y is also false. If x is false and y is true, then logical operation of x and y is false. If x is true but y is false, then if you do an AND, the result is false. If x is true and y is true, then the x and y is true. So from this table, we observe that only when the two variables are true, the result is true. The AND operation is true. But if one of the variables is false, the AND operation is always false, right? So this table kind of gives that visual to the understanding of AND operation, right? Similarly, when there's a logical OR between x and y, then if both x and y are false, then x or y is false. If x is false and y is true, x or y is 1, and it's 1 for all other possibilities provided. So from this table of logical OR, we observe that if either one of the variable is true, the result is true. So this is a very key takeaway, is in case of AND, both variables have to be true for the result to be true. But in case of OR, either one or both can be true and the result is still true. So OR is false only when both are false, right? So let's say there's an ice cream parlor, and they have a special that if you bring your buddy, you get ice cream. That's like AND. So if you go by yourself or your buddy goes by yourself, neither of you will get an ice cream. The only time you get an ice cream is when both of you show up, because that's the deal. So that's how AND is. So person X and Y has to be there to get the ice cream. But let's say when the special is over and you can just go to an ice cream shop and buy ice cream as much as you want, in that case, no matter either you go or your buddy goes, you both will get ice cream. And if none of you go, then definitely no one is going to get ice cream, right? So it's kind of an easier way to understand a logical AND and OR. Any questions here? All right, let's move on. So the next concept is compound Boolean expressions. So what is a compound Boolean expression? An expression involving logical operators evaluate to Boolean values, which means so far we have seen Boolean variables like Boolean X or Y, and then they either have true or false. So it's kind of easy to understand those are Booleans and they have Boolean values. But a lot of times, making a decision of whether to run a piece of code or not could involve checking multiple conditions. And when multiple variables are checked to get one output, whether to run the code or not, then it falls in the category of compound Boolean expressions. So it's not only based on one variable, but now there are more than one Boolean variables or other kinds of variables. But at the end, they all evaluate to one result, either it is true or either it is false. So such expressions are called compound Boolean expressions. So compound is because there are multiple variables involved, and Boolean is because they all evaluate finally to a true or false, which is of Boolean nature. As an example, if you look at the if statement inside this main, there are 4 variables here. In fact, sorry, there are 3 variables, right? So Java program, in order for it to get inside of the if block, it has to evaluate this whole expression. So let's see how Java will see this as, and A, B, C, and D are all integer types. If A is less than B, which is true, right? A is 10, B is 20, so that's true expression. There's an and clause here. B is equal to C. B and C both are 20, so they are equal. So both are true. And as for the truth table, you get the ice cream only when both you and your buddy show up. So as both expressions are true, the result is going to be true, and the code is going to execute if block, right? And then we should see the sum is whatever the D value is, right? So that's a Boolean expression. Now Java has something called a short-circuited evaluation, right? So operators ampersand, which is and or can be determined using only the first Boolean operand. So what do you mean by short circuiting, and what do you mean by the first statement here? What it means is, let's say, let's look at the if block again. So first, Java will evaluate A less than B. Now in that case, here, when A is 10, B is 20, the result is true. So when first value is true, the code will go inside the if block only when the second value is also true, because this is a ampersand. This is a logical and, so both have to be true. So in this case, Java will have to evaluate if B is equal to C or not. Now, let's say if A would have been 20 and B was maybe 10. So in that case, when Java comes and evaluates is A less than B, it finds that A is actually greater than B. So this itself evaluates to a false. Now, in an AND expression, if one is false, the final result is false. There's no need for evaluating. There's no need for checking if B is equal to C or not. Java can make a decision just by looking at the first evaluation. So it'll skip if and it'll go to else. So what did Java do? It just did a short circuit. It didn't check everything in the expression. It just checked the first condition that makes the whole expression false, and it just goes with it. Similarly, if this would have been an OR expression, now we know that in an OR, if one of the variable is true, then the whole result is true. So if Java evaluates the whole expression and finds at least one variable to be true, it just stops there, and it assumes it doesn't have to look at everything else because it knows one value is true, so the whole result is going to be true anyways. So it just goes through without checking everything else. So this is short circuiting. Why is it important? It's important to know is because a lot of times instead of variables, as in this example here, people may call methods, and those methods may return a Boolean value. And sometimes certain methods will not get called because the methods prior to them resulted in a true or false or whatever, and Java made a decision just based on that. So it's kind of a important concept to keep in mind is sometimes Java does short circuits when it comes to Boolean expression. So let's write a small program to understand what short circuiting is. This is what I had last time. I'm going to just delete them. Or maybe, you know what, yeah, I'll delete them for clearing the space. And let me, boom. Okay. Is this font large enough? All right. If not, let me know. So we are looking at short circuiting. So let's declare two variables. This is static, Boolean, call it operation A, print system.out.println, operation A was called, and this will return, let's say, a true value. Let's copy the method and have another one. Let's call it operation B. Change the string to print operation B was called, and let this return false. So these methods are not doing anything because we're just looking at it as an example. In real life, these methods might do like some computation, and then they would result a Boolean result of true or false. So let's look at short circuiting. Now, if I say if operation A is true or operation B is true, then print system.out.line either of the two were true, right? Else, what happens if none of them are true? Then we should print system.out.println neither were true. Let's save this. Now, what do we expect? Is we would expect Java to call operation A.
Sorry, I have a question.
Yes.
I'm getting errors. For some
What
reason,
error
like
do you
on
get?
my return true statement, when I hover over it, it says cannot return a value from a method with a void result type. Yet I said Boolean is my return type, not void.
Did you save your file?
I'll
Sometimes
try Control S.
I just save it. Control S, yeah.
No, it's still doing it.
Still doing it. Do you want to share your screen?
Okay.
Oh, wait, I'm looking at my own screen. Never mind.
It's like it's right here. For some reason, it's doing it on all these.
Wait, it's too tiny for me to look at. Return.
Oh, sorry. I'll maximize.
Yeah, kind of zoom in a little.
How do I zoom in?
I think control and scroll up. But that's fine. I
Maybe
can still see.
Control Plus. No, I don't know.
Now let it be. I can see. I'm
Okay.
well. Yeah. So what is it saying? Oh, this is because you have written this inside of the main method.
Oh. Okay.
Cut these and then paste it outside of the main.
So like all the way down here.
All the way down there or all the way up.
All right. I just
Doesn't
want to do it
matter.
up here.
Yeah.
So like inside this, but not inside this.
Correct. Inside of the
Okay.
class, but not inside any other method.
There we go. I think it's better
Perfect.
now. All right. Thank you.
Yeah, no problem. All right. So coming back here, so what is expected is when Java runs, it is going to call operation A and it'll find out what this method has to return. And then it'll call operation B and find out what the other method has to return. So let's see if we see three statements printed, which is operation A was called, B was called, and one of the statements from if else, right? So let's see what happens. So when you run the main program, all right, so it says operation A was called and neither of two were true. Oh, sorry, it's either of the two were true. So which means we observe that operation B was never called. We don't see operation B was called printed at all. So what did Java do? It looked at the first expression. It says, okay, this is true. The next is or. So the first expression itself is true. So no matter what the second operation is going to return, the result is always going to be true. So it didn't even bother about calling operation B, right? So now let's replace the or with ampersand, double ampersands. That's logical and. And then instead of either of the two were true, it has to be both have to be true for and to enter the if statement. And now let's see what the result is to be. So now we see that operation A was called and then that returned true. We know that. The operation B was called and that returned false. So it printed the else statement. Neither were true. We should have changed the else statement. But anyways, it proves the concept here is when Java has enough confidence or surety that the expression is going to be a true or false, it stops even trying the other operands. Right? So in case of OR, we were seeing that operation B was never getting called. So you don't want to be caught in surprise.
I have a question.
Yes.
Because it says if operation A and operation B were called, shouldn't it say, because that's true in that case, shouldn't it print that both of the two were true, not neither?
So the operation B returns a false, and as this is a AND, so operation A is going to return true, but operation B is going to return a false. So it is true and false is going to be a false.
Oh, so this if statement is if operation A and operation B were both true?
True, correct.
Okay. So that means that the else should have been one of them was true.
Yeah.
Okay.
Yeah.
Okay.
This should have been either one or both were false. Right? So, any questions so far?
No.
All right. So moving on. This is what we all wait for. Fun quiz. Right. What is printed by method mystery for fooling calls? So there's a method called mystery1. It takes an integer type value. It says if that value is less than 1, print the value. Else do a mystery, else call itself and pass half of the value and kind of print something out. So all right, let's see, Edward, what do you think option A will print? Edward? All right, Gavin? Wait, what? Did something happen on the chat? Let me see. Oh, Edward, no, we can't hear you. All right, so in that case, do you want to, I'll skip over to the next questions and you still own the answer to the first question. So when you're ready, just type it in the chat, right? Which means, Gavin, you will get to pick the second one. what will be the outcome of mystery and pass 4 as a parameter? What should this print? Are you guys able to hear me?
Yeah, I can hear you.
Yeah, I just can't hear him.
Yeah, I can't hear him either.
Yeah. Okay. Like, looks like Gavin and Edward both are having mic problems. All right, Grace, do you want to look at this question and see what
Hello?
option B would print?
Can you hear me?
Yes.
Okay.
Which one am I answering? Am I answering C?
So no, let's go with B. Answer B, and then we'll have Gavin look at C.
Oh,
So you can think out loud.
I'm not really sure.
All right. So is there something in particular that confuses you?
Are we supposed to plug in like the numbers?
Yeah. So the
Oh, okay.
the question is, if you call mystery with 4 as a parameter, then what would you see in the output being printed as? So in this method, if n is equal to 4, then what happens?
Would it just print out 4 then?
That's you're kind of
Wait,
correct,
'cause
but it does something very interesting before it prints 4. All right. So let's. Did Edward write any response to answer 1 yet? No. Right. Okay.
I
Then
joined
let's
with
all go over.
computer, so
Okay.
yeah.
Now we can hear you.
Yep.
All right. So do you want to take a guess at what the result of first expression will be, mystery 1? Because to understand everything else, we need to first understand what happens when the value of n is 1.
Okay. Isn't it gonna print n?
It'll print 1, right? So you're right. The reason why it'll print 1 is because when you call this mystery 1 with 1 as a parameter, the first expression is less than equal to 1 true. So you can just print 1 and exit out, right? Now, when we call mystery with parameter 4, this makes it very interesting. Now, first of all, if you observe this method, we'll see that in the else block, the method calls itself. Right? It calls itself. So when the program enters the method, and if it happens to go in the else block, it's going to call itself, right?
I think. Wait, I have a question.
Yes.
So okay, so if I put in the 4, because 4 isn't like less than or equal to 1, so that means I would does that mean I would move into else and then it should print out 2?
You're kind of guessing it very right, but there's a little gap in the guess. The reason is because we see that the mystery gets called by itself. It calls itself again and again. So if you all don't know what this is called recursion, right? So the method calls itself recursively. So from within the same method, you're calling itself again and again. So what happens? Let's look at when mystery is 4. So when n is 4, if block won't execute because 4 less than 1, no way. So it goes to else. Now in the else, it'll call itself, but instead of 4, it will pass 2, right? Because 4 divided by 2 is 2. So now we are back in mystery 1. N is 2. We look at, is n less than 3, like is 2 less than 1? No, it'll go back to mystery. And again, it calls itself, but this time it's going to be 2 divided by 2, 1. So it's going to print. Now n is 1, it's going to print 1. It comes back. When it comes back, the value of n is still 2, right? Because when it called itself, its value was 2, and when it called itself, am I explaining it, or am I making it more confusing?
I kind
I
of
think
get it.
I
I
understand.
understand.
Sort of
it.
makes sense. I just don't get why you'd use it because it's almost like repeating. It almost
Yeah.
defeats the purpose. Because why would you put in mystery 4? We can just put in mystery 1 and save all the calling back.
Correct. Well, the catch here is, if you write this program, you'll get. You know what? Let's write this. This is very interesting, and this is a very
Wait, I have another question.
yes.
So first, when it prints system.out print n, why does it say mystery n? Like, how does it know? Like, why would it print mystery again? Wouldn't it just print the value of n?
Is your print value of n? Yeah.
Oh,
Is it
because
printing?
the options for A, B, C, D, I didn't really get like that.
No. So, oh, my bad. So the question
That's what
is,
I was confused about the whole time.
yeah, it's not an optional like multiple choice question. The question is, okay, what happens if you call mystery and pass 1 as a parameter? What should it print?
Oh, okay.
Yeah.
Okay.
Wait, so it's basically always gonna do 1, right?
No.
No?
No. So let's look at it. It's very interesting. There's a lot of learning in here, and this is called recursion. It is a very smart way of writing a program. So you'll realize very soon we'll be looking at loop, which is going round and round in the program. And this is another way to do the exact same thing, but it's a very smarter way. So let's write this to understand it. So you all can kind of write this with me. Let's call it 3, and then pass a value integer n. Okay. So the method is if n is less than equal to 1. You may not get this type of question in the AP exam, but as you're learning Java, you must know recursion. System.out.println, or instead of line, we'll just do a print n. Okay. And the else does it calls itself. It calls itself, and it does n divided by 2. And then it also prints system.out.print. And we'll just print. What does it print? It prints a comma, puts a space, and then prints a value of n. Okay. This is exactly the same method that is in the question. Now, I'm just going to comment this out. Let's call this has to be a public static. Let's call the mystery pass 1. This is our A option, right? This is option A. Let's see what this has to print. We all know it's going to print 1. Well, it did print 1. Now the interesting find is, let's see what it prints for option B, which is 4.
Wouldn't you? How does it work if you define the variables after the code? Shouldn't it be before?
Variables after the code. I didn't understand. Come again.
So like the function is like above, and then you define mystery below it. So how does that work? Does it just take it?
So you're saying the mystery method has been declared here, but
Yeah.
used after declaration?
Uh-huh.
Yeah. So in Java it works, but if this was C, then this would have, well, even in C this would have worked because what we're doing is we're declaring the method first and then using it. But
Oh, okay.
if you would have done, if you had moved this method from above the main to after the main, then in C it would have failed. Is because when the C compiler comes here, it says, "Oh, I'm calling mystery, but I don't know where mystery is." It doesn't look any further. It just says, "Oh, I've not seen mystery so far," so it's some programming error. But in Java, it doesn't matter. It will still work fine.
Okay. Also,
Right?
how do you comment out like multiple lines at once?
So there are two ways to do that. Let's say this whole thing right here. So if this was a code here, then I'll select all of that and I'll press the command control key in Windows and command in Mac and press the forward slash,
Okay. Thank
and
you.
the IDE will do it for you. That's one way of doing it. The other way is to put a forward slash and a double asterisks, and where you want the whole thing to end, we put a single asterisk and a forward slash. That's
Okay.
also a multi-line comment, right? This is more elegant, but the other one is quicker. Right. So, did anyone get a chance to run Mystery 4 yet? What do you see in the output?
I ran it. I
What do you
got
see in the
2
output?
things for some reason. On
Because
the first line, I got 11, comma 2, and on the second line, I got just comma 4.
because you still have that Mystery 1 running.
Yeah. Should I get rid
Yeah.
of that?
So yeah, get rid of that. Yeah.
Okay. Comment it out. Run rerun. What? For some reason, it's doing the same thing. Even though I'm just
Doing the
running
same thing.
mystery 4. Yeah, it's just. Wait, actually, no, it's a little
Uh,
different. It's now it's printing 1, comma 2, comma 4.
yeah.
For me, they're on different lines, though.
For me,
Okay.
I'm getting errors under it. I don't know why. I'll wait them.
So, what I'll recommend is if you are running multiple mysteries, then put a print line statement after each one of them, and that way, it will separate out the output for you. So when, as an example, when I do that, then I get, for 4 I get 1 to 4, for 16 I get 1 through 16. Yes, and questions.
Yeah, I have a question.
Yes.
Wait, how does it work? Like, can you explain like the process of how those outputs come out?
Yes, I will do that. But before I do that, any questions about, for someone whom it's not working?
What is it supposed to say? Cause I have, so after I ran it, I have 1 and then comma 2, comma 4.
Because you still have the mystery 1 uncommented. So that prints 1, and then mystery 4 prints 1 to 4.
Oh, so should it be 4 and 16? Is that the
But put a system.out.print line between those two calls. That way
okay?
they get printed in a new line rather than on the same line. So the reason why you're seeing those things is because in the method, we are using print rather than print line. So when we use print, Java just starts printing right after the last print. But with print line, it goes to a new line and then prints there. So that confusion might be because of that. So after every mystery call, put a print new line. That way, the outputs will be separated on different lines.
Okay. Also, my indentation's kind of weird. Like it's choppy.
Do you want to share your screen real quick?
Yeah.
Meanwhile, you all who have this working, you can try to debug this. So the way you debug this is you can put a breakpoint after the line number, and then go to run, and then do a debug, right? So try to debug and understand what's going on. Meanwhile, I'll take a look what Parashar has to say. Okay, so indentation is off, and why is it off? Okay,
Like when I
so
press backspace, it just goes to that line, the line before it.
yeah. So that's because, okay, never mind. So remove the comment A from the line above. Yeah, delete that, and then go line, like go before the system dot output line. Yeah, hit back, go back all the way to the previous line. Like hit back on that again. Yeah, hit enter. Now it should fix your indentation.
Yeah, I think it did.
So what happens is when you have a comment on the previous line and you hit enter, then Java thinks you want to continue writing more comments. So so it does indent, but it puts / first, which kind of makes everything off by 2 characters.
Okay. Also, the run, like after I run it, it still shows up like this.
Because you have a print line, go to your method.
Is it here?
See, no, in the inside of the if block, it says print ln. It should just be print, right? Okay. Now you should have the right output.
Yeah. Thank you.
There you go, bingo. So let's come back to where we all left. So if anyone has any idea what's going on here, if not yet,
Actually, I think
then
I understand it now.
okay. So it's no more a mystery for you.
Yeah.
All right. Okay, let's wait. Let's wait. If anyone else has any questions? All right. So before you explain what you understood, let's try one more here. Let's put an. So far we have been putting multiples of 2, 4, 16, and so on and so forth. Let's put something which is not a multiple of 2. Let's see if, what happens when we put 29 in here. And then let's let me delete that. And then let's run the program. Okay. All right. So we all have this output. Do you want to go ahead and explain what's going on?
Me?
Yeah.
Yeah, like, do you mean like how we get the outputs?
Yeah.
Okay. It's kind of like an inception thing. That's the way like I thought about it. Basically, it's like a function inside a function inside a function, and then when one function ends, the one that was above it, like a level above it, finishes, and then the one above it finishes. So if we start with 4, let's say, so we put 4 in, it's gonna go to the else, and it's gonna run the function again, but this time it's gonna divide it by 2, meaning it's plugging 2 in. So then it's gonna go through the entire function again with 2, and this time it's gonna divide by 2 again, meaning it's gonna go through the entire function again, but as 1. And this time it's going to go into the first if because it's less than or equal to 1, and it's going to print out 1. Then after that's complete, it's going to go back up to the last level, and it's going to print 2 because that was the last level. Then it's going to go back up to the first level and print 4. And it just, for every number we do, that's what it does.
That's actually better than I would have explained. Thank you.
Wait,
Wonderful
so why does the
explanation.
order like switch around?
So the auto switch around is because we are printing it after getting to the next level. So if you would have printed this whole thing before going to the next level, your order would have been exactly reversed. So you can give it a
So it
try.
would be 4, 2, 1 instead?
Yeah,
Okay.
correct. So at every level, it saves the value of n from the previous level. So when you go back to that, it's going to recover that value of n and print it. So now if you run it just by swapping the print statement, you're going to reverse the whole thing. Well, there's a comma extra getting printed, but that's fine.
Also, for 29, why does it divide it and then round down?
Because we are dividing it by 2. Okay, let me run that so that I can understand the question better. In case of 29, why does it?
Like 29 divided by,
Yeah. So you're saying, like, after you like this output you're looking at, right? So 1, 3, 7, 14, 29, right?
yeah. So how does 1
And
become, yeah.
so what happens is when you divide 29 by 2, then when it goes to the next level, uh, the value of n is going to be 14. Yeah, 14.
14.5.
But this is an integer, so it's going to
Yeah,
drop
okay.
everything which is
So if we did it
fractional.
as a double,
Double.
it would make it more accurate, right?
It'll make it more accurate, yeah.
Okay.
Right. But that's well. While we are on the topic, it's a very good point. If this would have been double, then definitely it'll be more accurate. But there's one problem with double. The problem is comparisons really don't work well with double. Why does it not work with double? Is because the floating parts they can go on and on. So let's say in this case, it's just division by 2. So you can have zero point 0.5 maximum in the fractional part. But if let's say this was 22 divided by 7, that division never ends. So two doubles may actually have just a slightly different value in them. So they may be equally, they might match each other to almost to the end, but as it is an ongoing division, even if they're off by one point, they'll just say, "Oh, we don't match." So it's very tricky when you compare doubles. But you're right. If this was double, it was more accurate. All right. Let's move to the next.
Oh, sorry. I just have one. I have one more question.
Go ahead.
I wanted to see what would happen if in the mystery function I got rid of like the divide by 2 part, and when I did, it just gave me like 100 errors. Do you know what that is?
What did you try to do again?
I just got rid of the divide by 2 part because I wanted to see what would happen if it
Oh
just
yeah,
went on
yeah.
forever.
So you essentially created an infinite loop. This is what you did, right? You just put
Yeah.
n back in there. So what you did is you created an infinite loop, and then eventually the program will crash. So what happens is when you call the method again from within itself, we go to the next level of it, and every time we go to the next level, the computer saves the value from previous levels somewhere, so that when you come back to that level, it can recover it back. So if you keep calling this again and again infinite times, computer will eventually run out of memory because it's just storing the results, and you're never coming back. So it'll just run out of memory and give you an error. So when you run this, it'll try to run as far as it can, but eventually it'll terminate.
Oh, okay.
Right? There it is. So it tried to run as much. You can scroll as much as you can, but it'll just. So it says stack overflow error. It means it doesn't have enough memory on the stack anymore.
Okay.
Right? So, but that's a good experiment. It's a very common mistake people do sometimes that they end up in an infinite loop. All right. So next, move to the next topic. It's called De Morgan's law. All right, I told you, right? This session is going to be a little theoretical, but bear with me. It's important. Now, what De Morgan's law is, um, if you negate a Boolean expression, then the same Boolean expression can be rewritten in a different format. So let's say if a Boolean expression, if you do a not of A and B, then that is equivalent to not A nor B, right? So that's what De Morgan's law is. As an example, if there's car and truck, and you say not, then it means neither it is car nor a truck. Right? So you can convert an and operation into an or operation by negating it. Right? Make sense? So when you would like to convert and to or an or expression to an AND expression, then you would kind of negate it. And as per De Morgan's law, you would be able to do that in this case when it is AND. You do a not of each variable, and then all ANDs become OR. It's kind of very logical when you think of it, and this is just a mathematical or program way of writing it. But in your mind, when you think of it, it's like obvious. It's very obvious. If it is car and truck, and you do a not, then it is neither car nor a truck. Right? So let's say SUV, right? SUV is not a car, not a truck. So, it's kind of bad example, but let's see if this makes it a little more clearer. Similar to AND, the De Morgan's law applies to OR operations. So if you have A or B, then it can become not A and not B, which means if not car or truck, then it must be not car and it must not also be truck. So this is a table. So let's say if you have A less than B, then if you do a not, it means either A is greater than or equal to B, right? If A is greater than B, De Morgan's equivalent is less than or equal to. So what if you close your eyes for a moment and imagine about it? If let's say A is 5 and B is 6, is 5 less than 6? Yes, it is. But if you want to invert it, is B greater than equal to? Right. That's how we'll check to make sure that. Let me see if I can write it. Well, wish I had a whiteboard. But what I mean is, let's say there's an int A. Int A is 10. Int B is, let's say, 20. If I say if A is, let's say, for simplicity's sake, let's say B is 2. If I say if A is greater than B, which is true in this case, is same as saying if B is less than or equal to A. Right? Both the result is going to be give you the same result. So just to check if A is greater than B, either you can write if A is greater than B, or you can say if B is less than or equal to A. So first expression says A is strictly greater than B. So if let's say B was 10, then this won't evaluate, but the second expression actually will evaluate. Anyhow. The point here was if A is greater than B, then the second expression will also evaluate to the same result. So essentially, if you apply the same logic, if two expressions are equal, then if you negate them, then they won't be equal anymore. So if you say if A is equal to B, and if you say not, then neither A or A or B is not equal essentially. So it'll same is with less than equal to, which will evaluate to greater than equal to evaluates to strictly less than, not equal to evaluates to equal to. So they kind of switch roles in the De Morgan's law. You must read some of it by yourself and get some more clarity, because this is very subtle. It's a mathematical way of expressing what logically, the way we think. So there's a fun quiz. Well, any questions? Well, looks like
Wait, could you please go back to the slide before real quick? Thank you. Okay, I got it. I just need to review real quick.
all right. So, question is, if x is 2 and y is 3, what is De Morgan's equivalent of following, right? So who wants to go next? Hallie, do you want to go with what A will evaluate into? By the way, this is not multiple choice, so you don't have to choose one. We'll just go over each one of them and see what each one of them evaluates to. Hallie?
Yeah, hi, sorry, I'm just thinking about it.
You with me?
Yeah, sorry, I'm just doing it in my head right now.
Okay.
Yeah, would that be true?
So, that is true. Let's see. So the expression is not x is equal to 2. Let's call it. Let's have x is equal to 2 and y is equal to 3. So our expression is if x is double equal to true and y is greater than 4, so we need to evaluate this expression, right? So this can be so this is equal to saying as per De Morgan's law, this will become not of x equal to true, or so all ands become or, right? So or not of y greater than 4. What does this evaluate to? So x is equal to true. Is it true? Yes, x is equal to 2. So the first expression, x double equal to true, is going to be true. But so this will be equal to true, or this is going to be, is y greater than 4? Y is 3. So this y is not greater than 4. So it's going to be false. Right. So what happens? So this is equal to not of true is false, or not of false is true. So as it's an OR operation and one of them is true, so the final result is going to be true, right? So that's why this whole expression will evaluate to true. You guys with me?
Yeah, thank you.
Yeah.
Right. So in AP exams, you may get few questions of this kind, and the way you can kind of visually see this and evaluate yourself. But if using the De Morgan's law, it would have a few steps to it to come to the same result. So we can kind of see, is x equal to 2? Yes, x is equal to 2, and is y greater than 4? Oh, well, y is not greater than 4, so this is going to be false. True and false is false, but there's a negation, so the result is true, right? So we can kind of visually see this.
Sorry, you can keep going.
Okay.
I just have a question after.
I'm done. So if you have
okay.
a question, go ahead.
Is it also? I did it like a little bit of a different way. Instead, could you just do like first you just like forget about the exclamation point and just do x equals 2 and y is greater than 4. So you know that like the first one is true and the second one's false. So that overall statement is false, and then you just like you do the opposite of the false, which is true. So I did it.
Correct. Yeah. No, you're right. That's another way to do that. But the whole purpose of De Morgan's law, what you did is you evaluated the expression, right? You evaluated the whole expression and then you did a negation of it. What De Morgan's law teaches us is to decompose a statement. Rather than evaluating it right away, break it down into smaller parts first and then evaluate the smaller parts.
Okay. Is it
Right.
easier that way or something?
It depends on in the context of where you're using it. So sometimes you want to use and, sometimes you want to use or, right? So let's say here you're using and, right? Now, if you instead want to use or, then you would write this expression instead.
Okay.
But these two evaluate to be the same.
Yeah.
And De Morgan's law says it tries to decompose the problem for us, to break it down into smaller subproblems, and then it's easy to solve subproblems and then combine the result into the final result. Right?
Okay.
So just to practice, let's look at this another example real quick. So the another example is x greater than 2 and y less than 4. So let's say if you're not comfortable with and you want to break it down into or equivalent, so you'll do a De Morgan, which is you'll do a inverse of whole thing. So what this evaluates into is we'll just first it'll inverse x greater than 2, sorry, x greater than 2, and will become or, and then you inverse y and 4. So what is the inverse of this is this will become x 2 less than or equal to x, or 4 greater than equal to y. Let's see if this holds true or not. So is x less than equal to 2? That is true. Or so well, this is or, so our final result is going to be true, but still for the sake of is 4 greater than equal to y? This is false, so this whole thing evaluates to true, which means this expression would have evaluated true. Is that true? Let's look at it. Is x greater than 2? X is not greater than 2, so this itself evaluates to false, which means the whole expression within the brackets is false because there's an and then the inverse of false is true. So De Morgan's law did hold correct in this case, right? So we'll not look at all examples. It's the similar stuff. So look at this concept and revise it in your mind. It helps conversion from one Boolean operation to another type, and still the result will remain the same. We might come across it in something that we'll write a program very soon, and we'll see this where sometimes we don't want or, sometimes we want and instead, and how easily this helps to switch between. Any questions? All right, so you all can look at the remaining two as an exercise. Practice at home to get a hang of this. Right. Let's move to the next topic, comparing objects. So we have kind of been around this topic a few times already, especially during the strings object sessions. Now, there are two ways to compare, not two. There are three ways to compare objects. One is reference comparison, which is to check if two objects have the same reference, which means do two objects point to the same memory location? If you want to check that, then you'll use a double equal to or not equal to. So when you say obj1 is equal to obj2, it means you want to check if both the objects point to the same location in the memory, right? Or if you say not equal to, you want to just see that these two objects are different memory locations. The next way of comparing objects is to check for null. Now, sometimes, so we kind of looked at it in past, which is there's something called as declaration and there's something called as initialization. So you can say string str that's declaration. But the moment you say string str is equal to hello or is equal to new string, then that's initialization, which means you declaring it and also initializing the variables. Now, when you don't initialize a variable, when you say string obj, that's it. It means the obj is declared, it's not initialized. So its value is going to be null. It doesn't point to anything. It doesn't have any value. So if you want to check if an object has a value or not, is initialized or not, you will check if it is null or not. And the way you do that is obj is equal to null or obj is not equal to null. So this will tell you if object is initialized. So did someone call a new on it? So what happens if you don't check? So if you don't check for an object to be null and you try to use a method on it, your program is going to crash. Right? So it's always good to check for object whether they're null or not. The third way of comparing objects is to check for equality. So if you want to compare the contents of two objects, then you would use equals method. So the equals method is something that the object Java class has it, and every object in the Java world inherits it. So when you say obj1 equals obj2, then you're comparing the contents of the object and not comparing if they both point to the same object, right? So let's see if I still have the, okay, luckily I have the person program. And if you all have it, then let's try to put this to test. So I'm going to delete this just to make some space and for you guys to kind of have a clear view of my screen. So let's create a person object. Person Joe is equal to, it says imported, I'm importing it, okay. Joe is equal to new person. Does it have, okay, name, and I'll say Joe, and say a day is 1, month is 1. Let's keep it simple. Let's say person let's say, why am I going blank on right? That's it. So now, well, let's have Ryan. Let's have another person called Tom, and that is equal to new person. Let's say Tom 1, comma, and let's have another person. Jerry is equal to new person, but this Jerry is Joe, so his name is actually Joe. Day is 1, month is 1, right? So let's do a few things. Is if what is wrong? Okay, if Ryan is equal to null, we check system.out.println. Error. So it says it may not have been initialized. In this case, let's initialize it as null, which means we just declared Ryan. We didn't assign a value to it. Right? Now, second if is if Joe equal to Jerry. Now we know that both have same name, same date of birth, and same month. We'll see if the double equal to gives us any hint about it. Print line. Have different references. Well, same with this the else part. If that's not the case, then it must be different reference, right?
I have a question.
Yes.
I'm getting an error under like all the new people. Like create it says cannot resolve constructor person java.lang.string int comma int.
You might have a different constructor. In my case, my constructor looks like such. You
Oh,
might have a different
now
constructor. So in
mine's
that
just
case,
first and last name.
yeah, then just pass first and last name.
Okay.
You don't have to put date and month, right? Yeah.
Okay.
So that's going to check that. For Tom, let's just do equal to Joe. And then we'll run this again. And see if instead of Joe, we'll say is Joe is equal to Tom. And the final is we'll try the equals method. So I'm going to copy paste that and I'm going to say that equals Jerry. So equals checks if the content of object is matching or not. So here, the first we check if the object is null or not. Secondly, we check if the object references are same or not. And the first in this check we're going to get else. So we put another example just to get the right if statement executed. And the third is we're going to check if the contents of two objects are matching or not. Right? So equals does that job for us. Both have same content. So as we know that Joe and Jerry have same name, same date of birth, same month. So they should have same content and we should be able to see both have same content, right? So let's run this program and see what output do we get. Well, so ran is null. We know that because we have it as null. So this is a way to compare if an object has been initialized or not. So ran isn't initialized. The second statement is Joe is equal to Jerry. And it says both have different reference. But that is true is because Jerry is a new object, so it must have been created in a different location with the heap memory. But the third expression, Joe is equal to Tom, it says both are same references because when we declare Tom, we say Tom is equal to Joe, which means Tom points to the same memory location where Joe points to, so they have same memory reference. So that is expected. Now let's look at the equals. We know that equals compares the content of object, but it still prints both have different contents. How did that happen? Both of our objects have exactly same name, date, and month, but still the equals returns a false. So what did we do wrong? Any guesses? All right. So what did we do wrong was we did not tell Java how to compare the object. So we asked Java to kind of, where did I go? Okay, we asked Java to compare the contents of two objects, but Java doesn't know what contents the objects have unless we help Java with it. So in order to help it, we have to override the equals method and have our own implementation. Boolean equals. Okay. As this is an overridden method, all right, so it doesn't match. So what did I do wrong? I think, what did I do wrong? Equals public boolean equals, okay, it should be. Very interesting. Oh, okay. But let's do another way. Is 3 ways. Well, there it is. So the ID did bunch of things for us. Let's delete that. We don't need it. We can do our own comparison. So now we have to tell Java that how to compare two objects together. So we have reference to the current object, which is by using this, and Java passes us the second object as a parameter. So we'll say if O is pointing to the same memory location as the current object, it means it must be the same object, right? And true. So if both objects are pointing to the same memory location, it means it must be, it'll match, contents will match. But before you do that, O can be null. We don't know who passes O. So we'll check for if O is equal to null. If O is null, then there's no point in comparison because makes no sense. So they'll never match, return false. If both of them are not met, conditions are not met, which means these two objects are two different objects. So now let's start comparing their contents. So they are equal only when if their names are equal. So if this name equals o.name. Oh, so our name is private, so we need to have method to get the name. But before we do that, we need to person the name should be equal, and what else? And this dot month or day should be equal to a day, and this dot month is equal to day dot month. Just make sure we don't have any errors with order of operation. We are going to put them in individual brackets to evaluate. Then if all this is true, then return true, else return false, right? So now we have written a method or overridden a method equals, which Java calls when we call the equals method, and it'll check if object is null, then it is going to say false. The contents don't match. If the references are same, then you say yes, the contents will match because they both point to same memory location. But if neither of them are true, then we typecast the object into the type we want, which is person type, and then we compare if the names are equal, and the day of birth is equal, and the month of birth is equal. If all three are equal, then it is true, else it is false. The objects don't match. So now with that, let's see if we get an indifferent output. Run this program. There it is. The output changed. It says both have same contents. So now our equals method is comparing the contents of the class, right? So when you're comparing two objects for their content, you should always use equals method. The whole point of this exercise was to say that. So today we learned about comparing objects in three ways, checking if the references are matching by using equals and not equals to, checked if object is null or not. And then we looked at the equals method, which actually looks at the content of the object rather than references. So that brings us to the end of today's session on if and else's. So before writing a program, think, draw a flowchart in your mind. Remember the steps to boil water. Computers are not very smart. They're as smart as the programmers are. So make sure you understand the problem well, have a solution in your mind, and only then proceed. We looked at if else, and else if can be used to change flow of program based on conditions. We looked at series of if else's can be used to check multiple conditions. We looked at more than two Boolean expressions form a compound Boolean expression. Compound Boolean expressions always evaluate to one Boolean value, either it's going to be true or false. Not exclamation mark, which is and, which is double ampersand, or which is two parallel pipes, are Boolean operators. Double ampersand is true only when both expressions are true, or is false only when both expressions are false. And we looked at the truth table for these two to get a visual reference of it. And always remember the example of you and your buddy going for ice cream. You know, when there's a deal, you won't get it unless you both are there. We looked at De Morgan's law. Can be used to obtain equivalent Boolean expression. So if our Boolean expression has and in it and we want to use ors instead, then we use De Morgan's law and get an equivalent version of or, if you know, and vice versa. Object references can be compared using double equal to, not equal to logical operators. Object contents can be compared using equals method. So there's a distinction. Always remember that. When it comes to comparing primitive data types like integer, double, then use double equal to, greater than, less than, of those kinds. But when it comes to comparing objects and their contents, use equals. Any questions? No questions. So time check 8:20. All right. I think that's the end of the session today. And in the next session, we look at the loops. We kind of got a taste of it when we did the recursive call to the mystery method. And we'll look at different ways of writing loops in Java in the next session. Hopefully that will be quicker because there's only few things to look in that, and then we'll write a fun program together. All right. If there's no question, then we can call it end of session today. All right. So you all have a great rest of your evening. Let's meet next week.
Thank you.
Bye. Thank you.
Thank you.
All right, remember to make use of PK's additional help session.
Mhm.
And feel free to email to
sorry.
MX Irvine
Okay.
email ID. Zane?
It's a Tuesday at 6:30, right?
Yeah, so same time as the class, but Tuesdays.
All right.
But you gotta let them know in advance, okay?
Okay.
And make sure that you have the questions prepared. Thank you.
Thank you.
Thank you.
Sayonara.